This lesson is lesson 6.1. We're going to talk about rational exponents. A rational exponent is going to be an exponent where there is a fraction. And we're going to learn how to write those exponents, and we're going to learn how to change those exponents into different forms. So first, let's go back and think about some things that you may recall from what you've learned before. So we're going to talk about radicals. Radicals are when you have square roots or cube roots or fourth roots or anything with a root. So for example, square roots could be the square root of 2 or the square root of 3 or the square root of 4. And you know that that's what the square root is because it's just the root symbol. And then when you have a cube root, you do a little 3 on the outside. Let me erase that and use a different font. Use a little 3 on the outside of the root. So we could be saying the cube root of 2, or the cube root of 3, or the cube root of 4. And of course, fourth roots are going to be just like cube roots, except for they're going to have a 4 inside the little v. So we could have the fourth root of 2, the fourth root of 3, how about the fourth root of 16? So when we have a square root, there is no number. When we have a cube root, there's a 3, and when we have a fourth root, there's a 4. If it was a fifth root, there would be a 5, sixth root would be a 6. Alright, these are things we've actually used before. Now what we're going to do today is we're going to learn how to rewrite these radicals into rational notation. And I mentioned at the start that rational means we're going to have a fraction in the exponent. So this is actually really simple. If I have the square root of x, I'm going to rewrite it as x to the 1/2 power. If I have the cube root of x, I'm going to have x to the 1/3 power. If I have the fourth root of x, it's going to be x to the 1/4 power. And the fifth root of x would be x to the 1/5 power. So the root number, whatever root it is, a square root means 2, and a cube root means 3, and a fourth root means 4, and a fifth root means 5. So it's going to be 1 in the numerator over that number in the denominator. That's how we rewrite it from a radical, such as the square root of x, into a rational number such as x to the 1/2 power. Okay? So if I had, continuing on with that idea, if I had the sixth root of x, then I would write it as x to the 1/6 power. Okay? That's how you rewrite it when it's in a simple form like that. Now we're going to do some practice problems that have some rewriting, and some of it's going to have a little bit more than just the simple root. For example, if I have the cube root of 7, this is 7 to the 1/3 power. That's really pretty simple. But if I have the seventh root of negative 21 to the 3rd power, this is going to be negative 21 in parentheses, because I don't want to lose the negative, to the 1/7 power, and then all of that is to the 3rd power. So if I put it together, it's negative 21 to the 3/7 power, because if I multiply 1/7 times 3, you get 3 over 7. So basically what happened is this 3 that was here became my numerator, and this 7 that was here became the denominator. The denominator will always be the root, and the numerator will be whatever the power part is. So let's try another example with that. If I have the 8th root of 11 to the 7th power, well, I have 11 to the 7/8 power. Let me rewrite my 7. 11 to the 7/8 power. Because my root was 8, so it went in the denominator, and 7 is my power, so it goes in the numerator. So it's 11 to the 7/8 power. That may seem strange. It may not seem like something that you've seen ever before. Hopefully you haven't seen it before because this is specific to Algebra 2. But this is really important when we get to calculus for some of the calculations we have to do then. So it may seem strange to rewrite these things, but it actually does have a purpose. So let's see, if we can write the radical into rational notation, we can also take the rational and write it in radical notation. The radical means it has the root symbol. So if I have 17 to the 1/3 power, the 3 down here tells me what root I'm going to use. So it's going to be the 3rd root of 17 to the 1st power. I don't have to write the 1st power because anything to the 1st power just stays itself. So this is just the cube root of 17. But for 33 to the 2/3 power, the root is 3 and the power is 2. So I would write it as the cube root of 33 to the 2nd power. If I have 9 to the 5/3 power, my root is 3, and then I have 9, and I could put the 5 inside if I wanted to and write it like that, the cube root of 9 to the 5th, or I can write it as the cube root of 9 parentheses to the 5th power. Either way is okay because it's still talking about the exponent, and the exponent can go on the outside or it can go on the inside of the radical. Okay, so we have a few problems that we're going to evaluate, and I'm going to evaluate them just by seeing what is the problem actually asking me. So for this example, the cube root of 8 to the 2nd power, well, first of all, we need to know what number to the 3rd power equals 8. So what times what times what equals 8? And that's going to be 2. So the cube root of 8 is 2. And then I have to still square it. So 2 squared equals 4. So I did 2 steps here. I did the cube root of 8, and then I took the part now which is squared and squared both sides, and so that's what gives me 4. So the cube root of 8 is 2, and 2 squared is 4. If I try 4 to the 5/2 power, this is asking me for the square root of 4 to the 5th power. Well, the square root of 4 is 2. And 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 4, 8, 16, 32. For negative 8 to the 1/3 power, keep in mind that it's a negative. We cannot take the square root of a negative number, but you can take the cube root of a negative number, because a number that could be negative 8 would be negative 2 times negative 2 times negative 2. Would be 2 times 2 times 2 is 8, and 3 negatives makes a negative. So negative 2 to the 3rd power equals 8. So the cube root of negative 8 then is negative 2, because that's the working it backwards. Okay, this is a pretty short lesson. The assignment is 1 through 21 on page 96. You're going to work all of the problems. They're short, they're fast, they're easy, and then you can go on to the next lesson.